Alright, so how do we use integrals to solve word problems in physics? Let's look at this example. So step one, let's identify our givens. So in this question, it says at time equals 0, the initial velocity is equal to 10 meters per second, and the initial position is equal to 0. And at an unknown later time, the x position is 50 meters. And they also give us an acceleration equation. This models the acceleration as the function of time. This question, we need to find the velocity as a function of time and the position as a function of time. And to find these, we're going to need to compute integrals. So we're going to need the acceleration equation and the velocity equation. To find velocity as a function of time, we start with the acceleration equation here. Multiply dt on both sides, we get this expression here. Plug in the equation for the acceleration. So replace the ax variable with the equation and we get this. Apply integrals to both sides. Distribute the dt to each term, which leaves us with this equation. And the question can be asked, what are the limits of integration? So for t1 and t2, we know t1 is equal to 0 from the question. And we know that the question wants us to find the equation at any later time t. So t2 is just going to be equal to t. For the velocity integral, we know v1 is equal to the velocity at t equals 0, which is equal to 10 meters per second. And then for v2, it's just going to be equal to v, where v is just the velocity at any later time t. So with these limits of integration, we have this equation here. And now we can split these integrals up, and if we do that, we get this expression, and we can simplify by bringing the constant outside the integral and compute the integrals here. So the left integral is just the integral of a constant, so we just get t minus 0 for that. And on the second term, it's the integral of a power of t to the power of 1, so it's going to be equal to t squared minus 0 squared. And for the right term, it's also just a constant, so it's going to be v minus 10. We can simplify the expression, getting rid of the zeros, leaving us with this expression here, and then we can bring the 10 to the other side, leaving us with the final answer for the velocity equal to this. And I just want to note this is going to be the equation for the velocity as a function of time. We can do the exact same thing to find the position equation. Instead of the acceleration though, we start with the velocity equation here, bring dt to the other side. Then we can apply the velocity equation we just found and follow the same similar steps. And if you do that, you get the final answer here for the position.